Hopefully yesterday's lesson went okay. The big thing with yesterday is knowing what kind of triangle you're dealing with and being able to name it, like right, scalene, or acute isosceles, and then being able to find out the angles. And we know that the three angles add up to 180. Today we're going to talk about two specific kind of triangles. We're going to talk about the isosceles and the equilateral triangle. And we're going to start with the isosceles. So there are a few important parts of the isosceles triangle that we need to talk about. The first one would be the two congruent sides, and the two congruent sides of the triangle are called its legs. The angle where the legs intersect, so that would be this angle up here where they actually come together, that is called the vertex. The side opposite the vertex, so the one that's across from it on the opposite side of the triangle, is called the base. And the angles along the base, so the two angles that are touching the base, that's going to be angles A and C, are called the base angles. So that would be our main parts of the isosceles triangle. Now there's two theorems that deal with the isosceles triangle. So the first one says, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So what that's meaning is if we know that these two sides are congruent, then these two angles are congruent. In other words, if the legs are congruent, the base angles are congruent. And this theorem's sometimes called the base angles theorem. So if AB is congruent to BC, then angle 2 and angle 3 would have to be the same, or angle A and angle C, because those are your base angles. The opposite of that, or the converse of that, is going to say the opposite. So if the two base angles are congruent, so now we're saying if A and C are congruent, then the sides opposite them are congruent. So in other words, if angle A is congruent to angle C, then the sides or the legs would also have to be congruent. So it works both ways. So if the legs are congruent, the angles are. If the base angles are congruent, the legs are. So we can use that when we're solving problems. So like in example 1, I see that these two legs are congruent, which means the base angles are congruent. So that means if L is 68, then J is 68. And then to find our vertex, we know all three angles add up to 180. So 180 minus 68 would give us angle K. And that's going to give you 44. All right, number 2 is a little different. So this one gives you the vertex. So the first thing we're going to do is take 180 minus 106, and we get the number 74. So I know that angle C and angle E have to add up to 74, and they have to be the same number. So I'm going to divide that number in half, and we're going to find out that both of these angles are going to be 37. Because all three of them have to add up to 180, and because the legs are congruent, those two base angles have to be congruent. All right, now let's look at number 3. So number 3 asks us for YZ, so that's going to be this side. Now I see that the base angles match, which means the legs will match, so if one side is 12, the other side also has to be 12. And then to find our missing angle, we already know two of them, so 180 minus 77 minus 77 is going to tell us that last angle is going to be 26. All right, let's look at another example, like number 4. So on number 4, this one is giving us a little bit different setup. So I see that the legs are congruent, which means these base angles have to be congruent. So that means these two pieces have to be equal to each other. So we're going to set up our equation. And we're going to have 8x minus 30 equals 5x plus 9. Okay, so they have to be congruent, so they're equal to each other. And now we just solve. So we're going to subtract 5x from both sides. And then we're going to add our 30. And then we're going to divide by 3. So we're going to get x equals 13. And since all we had to do is find the variable, we are done with that problem. All right, looking at number 5, same kind of deal. So we see that this is isosceles, which means your base angles have to be congruent. So the two angles have to be congruent. We're going to set up our equation. 9x minus 33 equals 4x plus 7. So they're congruent. That means they're equal, and we're going to solve it. Subtract 4x from both sides. Then you're going to add your 33, so we get 5x equals 40. And then divide by 5, so x equals 8. Again, since all we had to do was find x, we're done. Okay, so number 6 uses the same concept. So this one is telling you that the angles match, which means the legs have to match. So that means these legs have to be equal. So again, we're going to set it up. 15x plus 7 equals your 23x minus 17. So I'm going to subtract 15x from both sides. So I'm going to get 7 equals 8x minus 17. Add my 17 to both sides. So 24 equals 8x. And then divide by 8. So I'm just going to get x equals 3. All right, number 7 is telling you the same information, just looks a little different. Again, it's telling us our base angles are congruent, which means our legs are congruent. So again, we're just going to set those equal to each other. So 9x minus 73 equals 3x plus 23. Subtract your 3x from both sides. So 6x minus 73 equals 23. Add 73 to both sides. So 6x equals 96. And then divide by 6, which is going to give us x equals 16. All right, on number 8, I know I've cut off some words here, but the question's saying that we have this triangle RST, and it gives us information about angle R, angle S, and angle T, and we have to find S in all the measures. So what we're going to do first is we're going to draw our triangle. So we have our triangle RST, and then we're going to mark RT and ST congruent. So that's the piece that we're going to need. And then I'm going to label all of the angles. All right, so since our legs are congruent, the two angles that we care about right now are going to be our base angles. So we know our base angles are going to be congruent. That means they're going to be equal to each other. So we're going to set it up. 13x minus 18 equals 9x plus 2. Subtract your 9x from both sides. So 4x minus 18 equals 2. Add my 18, so 4x equals 20, and then divide by 4, so x equals 5. Okay, this time we're not done, because now we have to actually find all of the angles. So I actually have to plug the 5 into each of these angles. So for instance, R is going to be 9 times 5 plus 2. So you're going to have 45 plus 2 is 47. We're going to have 13 times 5 minus 18. When you work that out, you should also get 47. And then when I plug it into the top, you're going to have 17 times 5 plus 1. Now that one, when I did that one, I got 86. So over here on the side, you're going to have x was 5. You had angle R was 47, S was 47, and T was 86. So same thing on this one. The first thing we're going to do is draw out that triangle. So we have a triangle. The triangle is DEF. And then we know angle D is congruent to angle E. That's what it's telling us right here. So then we just have to put our information in the picture. So you know that DE is going to be x plus 4. You know EF is going to be 4x minus 8. And you know that DF is 7x minus 35. So now when we look at our picture, we know our base angles match. So that means our legs match. So we're going to set those equal to each other. So 7x minus 35 is the same as 4x minus 8. They're equal. Subtract your 4x from both sides. Add your 35, so you're going to get 3x equals 27. And then divide by 3, and we get x equals 9. So again, we're not done just because we found x, because it actually wants the measure of every side. So we have to plug it in. So this becomes 9 plus 4, which we know is 13. This one becomes 4 times 9 minus 8. So 36 minus 8 gives me 28. This one is 7 times 9 minus 35. So 63 minus 65 also gives me 28. And now I can just fill in the numbers off to the side. So again, we had x was 9. We had DE was 13. And then our other two sides were 28. All right, so this picture looks a little more confusing. So the first thing I want you to concentrate on this one is the big triangle, so the outside triangle. So on that outside triangle, we can see that this is isosceles, like it's got two sides the same, which means it'll also have two angles the same. Once we can determine that, we know that this angle has to be 54. Well, I know ABC has to add up to 180. So 180 minus 54 tells me this angle B is 72. But angle B has been cut in half, and we only want half of that. So all we have to do is divide our 72 by 2, and we get that x is 36. All right, so now we're going to switch gears and we're going to talk about equilateral triangles. And the beginning of this says a triangle is equilateral if and only if it's equiangular, which we kind of mentioned yesterday that if it's one E word, it's the other E word. So for this first one, it says if all three of these angles are congruent, then all of the sides have to be congruent. So AC would have to be the same as BC, would have to be the same as AC. The converse of that, or the opposite of that, says if all three sides are congruent, then that means all of the angles have to be congruent. So angle A would have to be congruent to angle B, would have to be congruent to angle C. And I do want to point out, if they're all exactly the same and they have to add up to 180, on an equilateral triangle or an equiangular triangle, every angle has to be 60. There's no exceptions to that. All right, so looking at this one, I see that it's going to be, so I have to figure out what kind of triangle it is. So 180 minus 60 tells you this angle is 60. So we know it's equiangular, which means it also has to be equilateral. So all of the sides would have to match. All right, this one tells me that it's equilateral. It's telling you all three sides are the same. So we just kind of talked about this. It wants the angles. If all of the angles have to be the same, 180 divided by 3 tells you every angle has to be 60. All right, this is the hardest one. It just has a lot going on. So I want you to look at this angle first. So it says angle R is 7x minus 3, and it tells us this is equilateral. So we just talked about if it's equilateral, that means every angle has to be 60. So 7x minus 3 equals 60. Add my 3, I get 7x equals 63, and divide by 7, so I get x is 9. Now we're going to figure out the y's. Now I know that every side has to match. So I just have to pick two sides. It really doesn't matter what two sides I pick, and they have to be equal to each other. So 11y minus 23 equals 9y plus 1. Subtract your 9y from both sides. You'll get 2y minus 23 equals 1. Add your 23, you get 2y is 24, and divide by 2, so y is 12. I made the homework pretty short today. It follows the notes really, really well. I think the only one you might have some trouble with would be maybe toward the bottom. So at number 11, make sure you mark your picture like we did in our notes on problems 8 and 9. So just make sure you mark all your pieces and then you can work through it. That one's going to be a little bit more like number 8, just to kind of let you know. Number 10, make sure that you figure out what your vertex angle is supposed to be. So 180 minus the two base angles, which you should be able to figure out are both 29. And then your 11x minus 65 equals that number. And then I think everything else is going to be pretty straightforward. Number 8, it's equilateral, which means you have to know what that angle measures. So 4x plus 8 equals a specific number. We kind of figured that out on our notes for number 12. Also, we did one for x and number 13 the same way. So that kind of gives you some clues on the homework. Hopefully that helps you work through it. And if you have any questions, let me know.